For our next equation, we'll apply the square root property to solve a quadratic equation. We have the quantity 3x minus 1 squared on the left-hand side is equal to 75. So when we apply the square root property, we simply just take the square root of both sides of the equation. When we do that, the square root of 3x minus 1 quantity squared just gives us 3x minus 1 is equal to, if we take the square root of 75, we just have the square root of 75. But remember, when you apply the square root property, you really have two equations. We have 3x minus 1 is equal to the positive or the principal square root of 75, or 3x minus 1 is equal to the negative square root of 75. It's important to take both the positive and the negative square root of that constant term. So, in order to solve this, we'll first add 1 to both sides of the first equation, and we'll have 3x is equal to 1 plus the square root of 75. Let's simplify the square root of 75. Since 75 is really 25 times 3, we can rewrite this as 3x is equal to 1 plus the square root of 25 times 3. Now we can see that 25 is a perfect square. When we take the square root of 25, we get 5. So this is really 3x is equal to 1 plus 5 times the square root of 3. And we'll divide both sides of this equation by 3. So x is equal to 1 plus 5 times the square root of 3, all divided by 3, is one of our solutions. Let's go to the second equation. We'll add 1 to both sides, and we have 3x is equal to 1 minus the square root of 75. Since we just simplified the square root of 75, we know this becomes 3x equals 1 minus 5 times the square root of 3, since 75 was just 25 times 3. And then we'll divide both sides of this equation by 3, and we'll end up with x equals 1 minus 5 times the square root of 3 over 3. So our solution set is really two numbers. We have 1 plus 5 times the square root of 3 over 3, and 1 minus 5 times the square root of 3 over 3. And we can write that in the compact form as 1 plus or minus 5 times the square root of 3 all over 3.